Hello everyone, this is Manikumar Uppala of CSIT A section studying in Institute of Aeronautical and bearing rule number 22951A 3352. Today's my Tech Talk topic in artificial neural network is deep residual learning for object recognition. So now let's go to introduction to deep learning. Deep learning uses multiple layers in a neural network to extract complex features commonly used for tasks like image classification, object detection, speech recognition, etc. Performance improves as we increase the network's depth, but only up to a point. Need for deeper networks. Deeper networks can theoretically learn more complex patterns. Modern datasets. Example, ImageNet. It requires high capacity models, and simply adding layers does not always help accuracy. Can start degrading the visual effects or any high features. Challenges in deep neural networks: vanishing exploding gradients, training instability, degradation problem. Accuracy gets worse as depth increases. Optimization becomes difficult beyond a certain number of layers. So now we learn about deep residual learning. What is deep residual learning? And it was introduced by Keming He et al. In 2015 by Microsoft Research. Proposed a novel architecture, residual network (ResNet), and its core idea: instead of learning the full mapping, learn the residual difference. It means in ResNet we just learn the difference between models, so that the ResNet, it means residual network, will totally learn about the full map, and it skips connection, help bypass unnecessary layers. ResNet architecture overview uses shortcut skip connections to allow alternate paths to gradient flow. Each residual block output equals to f of x plus x, where f of x is the residual function learned layers and x is the input. Enables training of very deep networks up to 1000 plus layers. Structure of a residual block. A basic residual block contains two or more convolution layers and a batch normalization, re-low activation, shortcut connection that skips one or more layers, and the final output is addition of input, and the residual output is the final output. Identity mapping in ResNet. Identity mapping allows information to flow unchanged, helps maintain gradients during backpropagation, enhances convergence, speed, and stability. Degradation problem solved. Without ResNet, deeper models can perform worse than shallow ones. With ResNet, deeper models perform better without training difficulty. Allows very deep networks, example 152 layers, to be effectively trained. Now it means with ResNet, without any training also it will perform very better. But if we train without ResNet, if we train also, it performs very worse, because here we use ResNet where it has more than 1000 plus layers. It automatically uh, rechecks, so that it does not require any training. And if we train also, it can give better. But without any ResNet model, we if we train the model also, it cannot perform good. ResNet variants: ResNet 18 layers it has, and ResNet 34, it is deeper for simple classification task, and ResNet 50 introduces bottleneck layers, 1 into 1 convolutions. ResNet 101, ResNet 152 for very high performance tasks, example for any face detection or any voice detection, we use ResNet 101 and ResNet 152, and available as per pre-trained models in framework like PyTorch, tensors. Training and optimization: dataset typically trained on ImageNet, where 1 million plus images and 1000 classes, and optimizer SGD with momentum. And dataset training: this portion of a dataset is used to teach a machine learning model. The model learns patterns and relationships within the data by adjusting its internal parameters and structures of a face and movements where we train the data. And optimizer SGT with momentum. This refers to the process of improving a machine learning model's performance. It uh, like hyperparameter tuning, and algorithm selection, future engineering, and this all comes under this. And data optimization, data pre-processing, data augmentation, data quality and integration. Then regularization: batch norm dropout, faster convergence than plain CNNs due to residual learning. Application in object recognition, image classification, example ImageNet challenge winner. Object detection with faster RCNN, mask RCNN. And for face recognition and medical image analysis, real image video recognition, ResNet plus YOLO, and by and or SSD. Advantages of ResNet: it enables training of very deep networks, mitigates vanishing gradient problem, improves accuracy with increasing depth, easy to integrate with other architectures, works well even with small datasets using transfer learning. Limitations of ResNet: more computation and memory usage, still requires large datasets for best performance, identity shortcuts may not work well for all tasks, can overfit if not regularized properly. Real world use cases: in self-driving cars, object detection and scene understanding, and medical imaging, cancer detection, X-ray analysis, and security, facial recognition systems, retail, visual search and product tagging. Then go into robotics, object classification and navigation. Recent research trends: ResNext, DenseNet, further improvements on ResNet idea. Vision transformers VIT, competing competing the with CNNs is performance is competing with the CNNs in performance. Hybrid models: Hybrid means combining of two models. Here we are combining ResNet plus transformer. It is a hybrid model to recognize uh, any object or any type of visual effect. And efficient net, ResNet like performance with fewer parameters. Conclusion: ResNet revolutionized deep learning for vision tasks. Residual learning allows for better training and deeper models, still widely used and extended in modern architectures, continues to influence new research in neural network design. Thank you everyone for this opportunity.